Alrighty, so this is going to be just the initial kind of what's in the box type deal for the Det3 digital ECU tuner. This is the 3 Plus. We're going to talk about that. Discover the hidden power of your engine. Absolutely. So slide this out. As you can see, there's not much to it. I mean, I'm about to shock you right here, because the module itself is only about as big as a deck of playing cards. And this is a deck of playing cards right here. You can see it's not much. Matter of fact, it's probably not as big. So it's a very small computer. And this one here, you'll see that there's a USB with a nipple on it. We'll talk about the nipple. Here's your plug-ins. And look, to note is this little tab right there. That's important later for wiring the unit. So on the front, you got just a basic statement of what it is. On the back, if you don't have which you should have, the manual. This one here has got the plug, and of course you can see up here it's got the little top I just showed you. All the cavities, what the cavities do, and that's about it. That's all there is to it. Look how tiny it is. And it does a lot for what it is. It gives you a USB cable in here for your laptop. It's USB to USB. Inside here, with all the guts hanging out here now, this is your plug-in. This is what you're actually going to be wiring in. You're going to be taking these pins that they give you. There's 20, let's see here, 8, 10, yeah, there's 20 of them, so they don't give you any for any mistakes. So if you mess up, you're going to have to order another set, a complete set from Ecumaster. Along with it, they give you 2, 4, looks like 5 diodes, resistors. I'm not sure what the ratings on these are. I don't know if I imagine the color coding has something to do with it. I'm not sure what the resistance is of these. I'd have to email and ask, I imagine. I don't see anything in the installation manual that talks about what resistance they are. So I'm not sure on that. I'll find out for you 100%. And short of that, there's a warranty card in here, and it's got a you scan it, and I imagine that has some information there. I don't know what yet. I haven't scanned it. I went ahead and just went to the site and downloaded all the stuff. Here's another one right here. A couple stickers. There is no CD in here. In the owner's manual, it says that there's a CD, but with the advent of downloads now, it seems to be unnecessary. These resistors, these pull-up resistors, they serve a purpose. There's several different times you'll use them. Sometimes, depending on what you do, you may not need them at all. So we'll get into all that. But basically, that's all that's in that box. Pretty straightforward. Now, the unit chip that I plan to use for the Toyota setup, just because they're more Toyota friendly, this is not only a little bit bigger, but I mean it's beefier. This is like aluminum, where that other one is plastic. Multiple more pins involved here. So, and this is the Q Plus, in case anybody's wondering. But just to give you some variance or some difference on how big the other one is. This one's it feels like you got something really beefy here compared to that other one. That feels like there's nothing inside it, but it works. Alright guys, so this is going to be the first of many videos pertaining to the Det3. That is basically, it's the digital ECU tuner, and what I'm going to try to do is go through these things and kind of just go a few pages at a time, to kind of just do a real lethargic and basically an intentful um, introduction to it. Now, some of what I'm telling you now was very early on, so there may be some changes. So what I'm going to recommend you do is watch all of these before you attempt to even buy it or to install it, because there might be some changes that come up in later basically installments. And the reason for that is, once again, it's a Saturn, okay? And so the Saturns, even the Saturn, the way that they do the crank sensor and the pickup on the Saturn, they call it a 7X, or a 7 times reference signal. It's much different than anything else out there, except when the Ecotech engine came out, the 2.2 and the 2.4. They use almost an exact replica of what Saturn used when they did theirs. So just to give you a quick kind of jump to the kind of scenario, when I first got this, I contacted the sales department, and I was ready to return it only because I didn't have the updated firmware on the software that I had downloaded. I even had the actual digital 2, and so it looked really simple, and I kind of lost some confidence when I saw it. But they turned me on to the actual software, downloaded it, been playing with it. Very simple. The only thing is, when you're kind of doing this stuff, and I'll show you where you go in and you select the ignition mode and all this stuff. When I did that original software download, even with this, the Det3 software, it did not have all the available ignition modes, and I got kind of disenchanted because when I wrote the sales and got some guidance on it, they said they'd have to contact their engineers, and I'm like, oh crap, Saturn 5.0 here. Nobody made anything for this dang car. And so he finally got back to me a few days later and said the engineer team said use this mode and this and so forth. And since then, he's kind of talked me into it. Now, who knows? But I mean, I'm moving forward with it nonetheless. To give you some idea, the user's manual for the Det3, I'm gonna scroll real quick down here. It's 47 pages long, right there. The unit chip, 700 and something. Now, even of these 47 pages, we're only going to be using a fraction of them because, for instance, there's a section in here that if you have a MAF sensor, a mass airflow, which we don't, ours is a MAP sensor, manifold absolute pressure, that doesn't pertain to us. We're not trying to convert a MAF signal or convert a MAP to MAF and so forth. So some of this isn't going to apply to us. Okay, so the other thing too is you got to have some level. I mean, I'm ultimately just going to show you what I came up with for wiring diagrams. I actually went in and got the Saturn wiring schematic, identified the wires that I need to use. Now, the only difference between what I'm going to show you and what you may end up doing is, except for, and you'll see in here it's called analog 1, 2, 3, and 4. Analog 1 is typically going to be used to draw in and intercept the stock map sensor on the car, and then 2, analog 2 is used. It's not used. You don't plug anything into that if you've got a boosted car, and I'll show you why. And then you got analog 3 and analog 4, and those two you can pretty much put any sensor in there that you want to monitor, make corrections off of the signal for, and things like that, and we're going to get into all that. So first, I want to just start off the digital ECU tuner. I'm going to call it the Det3 from here forward. The Det3, there's a Det3 Plus and a Det3 regular. The Det3, the sole difference, you'd wire it up the exact same way for the most part. The difference is that the Det3 Plus has a built-in 4-bar map sensor. The Det3 does not. So let's say that you have a setup and you just want to run nitrous, the Det3 would work for you. However, if you've put on an aftermarket turbo, you're going to have to use the Det3 Plus, and we'll go into the reasons why that is, but you absolutely have to use the Det3 Plus. One quick note here, since I started doing all this stuff, I reached back out to a local tuner here in the Dallas area. I say here, I'm in Houston. And I said, hey, quick question. I see that you're a ECU master distributor, you know, and I was wondering, once I get this on here and I do some street tuning and I get it as close as I can, who do you know that is familiar with the ECU, the Det3 system, to be able to go in and on a dyno, go ahead and get it, a little bit better than what a street tune is? That guy sent me back a 1 sentence reply. Nobody in their right mind would touch that system because of a liability standpoint. Now, I have to be honest with you, that kind of pissed me off because, look, you're a distributor, okay? You're an authorized dealer for ECU Masters. And ECU Masters sells the Det3, the Det3 Plus, so it's a product of theirs. How can you, as basically a dealer, sell, maybe he doesn't sell them, I don't know, but I know that ECU Masters did because I bought one from them. How can you as a dealer knock a product like that? Wouldn't a better response have been, hey, congratulations on purchasing the Det3. The way that system is, I honestly don't know of any dyno tuners that would be willing to put it on their dyno and try to tune it, only because it can be kind of grumpy and maybe not give the results we want, and tuners really won't want to try to take a chance with that. But I wish you luck with it. It is a good product for those people who are on a budget and have a small setup that don't need full standalone. Why couldn't it have been like that? So anyway, I emailed sales at ECU Masters, kind of told them what was going on. You got a dealer that, it's okay, you can't help me, just say it differently. Don't knock the product. It made me feel like I made a real bad decision getting this, and that as soon as I fire this thing up, it's going to blow my car up. So, but that's not the case. And you know why I know this? Is because unlike the Unichip, the Det3 has tons of YouTube installations. Now, some of them are in Polish, and there's one on there that I was watching to get a better familiarity for the dynograph and how you can use that. And it had English subtitles, and it was good. I mean, perfect. But there's a lot of Det3 YouTube installs, users, and things like that. I actually got a lot of information, and I want to send a shout out to Dan's 91. He has a Toyota Starlet that he put one on. He pretty much did an aftermarket turbo system and bought that, figured it out, installed it, and was running it. And sadly, someone T-boned his car, so he's working on another project to try to get it run. But I've asked him several questions, and just to get a better understanding of what has to happen. And so the bottom line is, it is something that is viable. Now, granted, if you're an all-drag car, you're running 1,400 horsepower, 2,000, and you're going to need a standalone. There's no doubt about it. But if you have a 5-pound system, a 7-pound system, in my case, even a 17 or a 20-pound system, that is doable for this tuner. And for someone to suggest that this thing isn't worth anything, it's going to blow your stuff up, nobody in their right mind would take it, that's ludicrous. It's ludicrous. Okay, so I'm off my soapbox. Let's get into this. So this first segment, I'm going to try to keep these things down to a reasonable length, each one of them. So just kind of take what I'm telling you, wait for the next installment. I probably will insert some other material in between each one, but rest assured, from the day I install it to the day I crank it up and start tuning on it, I'm going to post on here what I got. And in the end, I hope to be able to help you get something installed on yours. So, okay, so Det3, this just says Det3 here, but I did buy the Det3 Plus. It's got launch control, it's got speed limit removers. You can do all kinds of stuff with this thing. And like I said, I think it meets the need for most of your run-of-the-mill setups out there. Um, it's a USB setup to where you'd plug in a USB to your USB laptop and you would communicate, edit, download, and all that stuff. It's got one block of pins, and I think when I got done kind of running each one of mine, I think I'm using a less than 20 of the ones that are available. Um, and I'm going to be running boost control on mine. The the speed sensor limiter, and all kinds of stuff. So anyway, the difference, this would be the Det3. If you had a Det3 Plus, it would have a nipple on here, and that would feed the internal map sensor. Okay, it's a 4-bar map sensor. And so as I scroll down here, it's just the beginning. I'm going to go ahead and go full wide here. Okay, so first couple pages, it's your standard disclaimers. Of course, I got to say this. The EPA is cracking down on crap, like the Nazi establishment that it is. Only use this on motorsports. Don't use it on public roads. All right, that's their cover your ass kind of statement right there. Trained specialists that only do this. Incorrect tuning of the vehicle can result in serious damage to your vehicle. Don't modify the settings if you're moving. Of course, ECU Master is not responsible for damages, of course. All right, so 1.0 version of digital ECU, this is the Det3. Now, one thing you're going to want to do, and we'll get to that here in a second, is when you get this software, go ahead and do the firmware update. That's going to basically give the latest and greatest version of the software that has all those extra options and things on it that you're going to need. They say here, always use an air fuel ratio meter when you're tuning with the fuel settings. I concur. All modifications of the engine's wiring loop device must be performed with unplugged battery. Make sure you got the battery unplugged or disconnected when you're cutting wires, joining wires, etc. You don't want the wire connections to be longer than 30 centimeters. That's going to be about 11 inches, 12 inches, something like that. You don't want them to be longer than that. Now, I suspect, my thinking mind is, and I may be wrong, there's resistance in wiring. Okay, so the longer the wire is, the more resistance there is. And when you're talking about you're running 0 to 5 volts through these wires, the longer the wire, the more resistance. Signals that you need to be a certain volt, 2 volts, 0.06 or 0.6 volts, 0.5 volts. If you got resistance in that line, then when you should be receiving a 0.5 volt, you may only be receiving a 0.3 or 0.4. And so keep them about 11 inches long. And that basically means all your wire connections, you're going to be pretty close to the actual ECU, all right, your computer in your car, your factory one. Variable reluctance sensor signals should be used. You should use shielded wires or shielded cables. Now this is going to come into play for your crank sensor, and if you're going to want to have a speed sensor clamp, in other words, you're going to go faster than what the stock PCM will allow you to go, and you're going to clamp that voltage signal, then you're going to need to use a shielded wire. All right, and I think I priced them on the internet the other day, and I mean for like a foot or 3 foot, it's a few dollars a foot, so it's not really bad. Just hunt around, find something. Every unused input should be connected to the ground. And so like we were talking earlier about how many of these are you going to use. You've got 4, and they're inputs, analog inputs, and some other inputs. Any ones that you're not using, they want you to ground those. So you would run a wire to it and then just ground it. Here's an important one, since we're probably never done with our projects. Once you get this thing on here, you need to disconnect it while you're welding on it. Okay. I think that's the case on today's cars. They would probably tell you not to do that. I'm thinking because that thing's no bigger than a deck of cards, it's a little computer. Maybe a bigger stock ECU is a little more robust, can maybe take something like welding on the car, because I don't ever disconnect my computer if I go to weld on it and stuff. But on the car, but just do it just in case. You don't want to go through all this effort and then crispy critter it because you were too lazy to just reach under there and depress and pull. Okay. All right, so tables of contents, won't bore you with that. Down to page 4. This just basically tells you what the Det3 does. It's going to just basically, it's a piggyback, and you know this already. So what it's doing is it's taking the true signal, okay, what's actually happening on the motor, what the actual temperature of the air is, what the actual timing is, and it's having you intercept that signal as on its way back to the ECU, because once it gets back to the ECU, based on what it got from the sensor, it's going to make new changes and send them right back out. And so what this thing's going to do is it's going to basically intercept the true signal. You're going to go into your maps on this thing and you're going to tune it, and you're going to add here, take away there, and then it's going to then take that signal and send it to the ECU, to your stock ECU. And I'm going to say that a lot, because if I just say ECU, am I talking about the Det3? Am I talking about the stock ECU? So the stock computer, you're basically lying to it, okay, with what's the true state of the environment is on the engine. And based on that lie, the computer doesn't know. It doesn't know that there's an intercept device lying to it. It just has to believe what it's seeing and make changes accordingly. And that's what it does. It goes on here and talk about 4 independent tables, and there is 4. There's fuel timing and 2 pulse width tables. Just tells you right there. 16 by 1 maps, and that's true. Now 2 independent switch table sets. Now what you can do is, let's say that it's a daily driver for you, and you realize that dailying a car and trying to run 20 pounds of boost on it whenever you decide to get frisky may not be a longevity kind of mindset. And so you say, okay, well, I'm just going to run 10 pounds 90% of the time. When I feel like I'm going to race somebody or something like that, I'm going to have this second map. Now this map, you can literally, as the car is running, you're sitting at a stoplight, you shouldn't do this, I should add, but you're about to race somebody. You reach down, you find your toggle switch, or your little, whatever switch you want to use that has a 1, 2, or on, off, whatever, and you flip it, and it automatically, even while the car's still running, it switches over to that second map set, where now you've got it tuned for 20 pounds of boost. So you would have had to have separately tuned 2 different sets of maps, right? So you would have safely mapped it to run 10 pounds, and then you went out and you safely mapped it to run 20 pounds on these 2 different maps, and now you're switching back and forth to them. It's that easy. A lot of this stuff here is, this talks about, now when I first got the firmware, this was all they had in there, the ignition types, and none of these apply to us. 60 minus 2, 36 minus 2, 36 minus 1. Now what this is talking about is the reluctor wheel or the crank wheel that has all these teeth on it. Well, this one would be 60 minus 2, so it'd be like 60 teeth, and there's a big gap right there. And that's how the crankshaft, or in this case probably a Hall effects, picks up where the timing's at when it should fire. There's EDS, multi-tooth ignition modules. Look, lucky Subaru. If you have a Subaru GT, man, it's made for you. Honda D-series. Actually, they've got a wiring set up here for a Honda 1.7, which is my daughter's EM2, I want to say it is. I'm not real savvy on the Honda stuff. Boost control, you see that. Now here you can actually, they have a different a different software manual. You can actually basically take off your connectors from your injectors and then wire in new connectors, or basically just snip the wires and cancel them, and you can run those injectors off of the Det3 alone. It's the fit setup, and it's this one. It's called fuel implant, and basically it goes in, it shows you how to wire all that up and things like that. So it's got launch control, so pop 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 pop. You can go online and watch a few episodes. You know, this can be as aggressive as you want it to be. I don't suggest doing it too aggressive because it's not good for your turbo, and with mine being a rear mount. So basically what you do at that point is you cut timing back quite a bit and you add fuel, and the fuel goes down into the exhaust and basically lights off in the exhaust, and that artificially creates a boost environment. That's how you can build boost while you're sitting at a stop. Otherwise it would never do that. It's got a road dyno, all right, and it's got parametric output, which you can control nitrous, solenoids, all that stuff. This talks about taking a map sensor, calibrate analog sensors, which enables analog values to be displayed in their real values. So you can actually make a run, go into your air and click on air fuel ratio, and it'll show you what your air fuel ratio points were on the map, and you can make changes based off that. So it's not to be understood for like a self-tuning kind of feature, but it will go in there and show you, say for example, at 3,000 RPMs and you're into 5 pounds of boost, it's 15 AFR. Well, we don't want that at that point. We want to bring that AFR down. So you go into those same cells, add some fuel, make another run, and your next run may show that it went down to 13. You go add a little bit more fuel, make another run. Now you're down to 11.5. That's your sweet spot. So it's pretty cool in that way. Free firmware upgrade, like it says here, new ignition modes, that was important, additional functions. So over time, if they continue their support for it, because who knows, maybe they're done with it and they're trying to move on. Now this same company, I should add, Ecumaster's, has full standalone. They got all these different modules, and I'm thinking someone with a race car, they're gonna have like 7 different modules to control crap. And but anyway, I won't go back and beat that horse. The basically your the setup that you have to have for your laptop has to have these minimum requirements, and I think laptops from the 80s probably had this much. So yeah, you can run it. It's no big deal. It tells you what's inside there. I did not get a CD with software on it. I think they're probably doing away with that because you can download it. Okay. I should tell you too, these let me see if this one has it. Yeah, see here, that's Polish, and this is a wiring guide right here. So every bit of this is in Polish, except when you get down to the wiring guides. Look, it's English. Pull up, frequency out, ignition out, crank sensor, MAF sensor. So I don't know where is the diversion here. You know, you would think they would make these in English. I don't know. But this kind of angers me. Look at this real quick. Here's a wiring diagram. Someone took the time at ECU Masters to figure out how to wire this thing into a Daewoo. As far as I know here in the United States, they don't make Daewoo anymore, and that's been the case for the last 15, 20 years. I used to have to go to a specific vendor here in town, and I'd have to prepay for parts if I ordered from Daewoo to fix my customers' cars. We'd get one every blue moon, and now I don't see any at all. But you see, there's no love for the Saturn. I mean, holy cow, a Daewoo Espero? What the hell is that? Did they sell millions of them? I doubt it. Did they sell millions of S-series Saturns? Absolutely. So I've never understood where the break was on something like that. Daewoo Lanos. So I won't get too much into this. I just want to show you that if you were to have one of these cars, it would take you right to the wiring diagram. Your work is over. Here's that Honda Civic 1.7. My daughter's car is a 2003, so I could use this one to hook her car up with. See, it'd be that easy. Alright, so back over to here. Firmware. Okay, first thing you do, update the firmware. The latest firmware can be found at, let's go ahead and Trying to connect to, let's allow that. So we go to ECU master, if it'll actually load. Looks like it's going finally. Doesn't usually take this long. I'm probably downloading a virus from them or something. Don't even know it. Nah, we ain't gonna waste our time. But anyway, you'd go there and you'd upload you would download the firmware update and put it on your laptop. And it talks you through the firmware update right here. Fairly straightforward. By the way, it says here, updating the firmware causes the loss of the saved tables and setup parameters. So one thing you want to do when you first get this software is update the firmware. The last thing you want to do is, after you get it all tuned up and all this stuff and you got it set and you got the current going, and try to update the firmware, because you're going to lose every bit of the stuff you got in there. So if you're going to do that, you're going to want to go through in each window and copy where you're at on each window, how you have things set. Then you could update the firmware and then go back in there and re-input all your stuff. Kind of chintzy that has to happen, but very important. So first get the software, update firmware. After you've tuned it, don't update firmware unless you're certain there's a new version. And of course, like I said, go in and make sure all your parameters are recorded so you can just go back in and put them all in again. Alright, so here's where we get to the connector pin data. I'm going to probably just concentrate here a little bit of time, because what I'm going to show you here is it's not going to make a whole lot of sense initially, but later it will, and we'll go back to this. But what I've done here is, when you look at the Det3, the connector, it's got 20 cavities, and it's numbered 1 through 10 on the bottom, 11 through 20 on the top. So, and this is very important, the front view of the device. So when you're looking at that plug, it's going to have the snap release up here on the top. When you're wiring these things, you're wiring them in looking into the connector where the wires would go in. Okay, so that's pretty important. So you need to make sure that you pay attention. Now, see how some of these are squared and some of these have a different shape? They do that for a reason. So for instance, pin number 1 right here. Try to highlight just that if I can, and I can't. That's going to be your switch 12 volt. Now this is the power supply after the ignition switch, which I'll show you the wire to tap into. You want to tap into the same wire that's 12 volts switched for your ECU. Again, you're going to be no more than about 11 inches away from it when you do that. You're going to want to put an inline 1 amp fuse there, okay? And I just got a note, splicing the 12 volts to the ECU. 12 volts switched. There is a 12 volt constant, actually a couple of them, that go into your computer. You don't want to splice into those. This Det3 would be on all the time, okay? So you don't want to do that. So if you look, let's say that you've got this thing turned around and you look at this spot right here and you believe that this is where 1's at. Well, 1's not square. I mean, 1 is square. This number 10 is not. So you don't want to put it in this one. You want to make sure you're on the bottom row where the square's at. That's where you're going to put in 12 volt switch. Now I'm kind of over exaggerating this a little bit, only to tell you that you want to pay attention, especially the first few, so you can make sure you're on track and you got it in the right. You're just pointing in the correct direction, so you can put these things in the right way. You would not want to put 1 into 10, because 10 is frequency in, and that's used for your speed clamp, for your vehicle speed sensor. Okay, so here's that map switch. That's number 2, and so you would wire in if you want 2 maps. Okay, that's if you do, and it's a real simple setup. You're just basically hooking. You'll have a wire here coming out. You'll have your switch that you're gonna, you want your 2-pole switch, and then you're gonna ground the other side. It's that easy. And then you'll be able to switch between 2 maps. I'm not going to go through all this right now. The only thing I did want to show you here is right here, 13 through 16. Okay. These are analog 1, 2, 3, and 4. So 13, 14, 15, 16. This is going to make sense here when I get into the software, because these are all analog inputs, and you can put whatever you want here except these first two. So analog 1N is going to be your factory map sensor. This is going to be an intercept. Now there's two different connections, intercept and splice. Intercept is where you're going to cut the wire. You're straight up going to cut the signal wire, and you're going to put it into cavity 13. Okay. Now analog out, if you look at number 17, analog out is where you would connect the other side of that green wire. It's a green map sensor wire to your ECU. So basically the signal, the true signal coming in, or that was on its way to the stock computer, it goes in here, and then it's played with, and then it comes out here and goes on to the stock ECU. So that's basically, this is an intercept. Analog 2, you're not going to put anything here, because this is your internal 4-bar map sensor. You don't want to have anything here. Okay, analog 2. Now here's these two here, you can have what you want. I personally have put, or decided to put, my wideband O2 sensor signal. I'm going to basically tee off of that and have it feeding in here, so I can have readings of what my wideband air fuel ratio is, and you need that when you're tuning boost. Okay. Number 4, you could put coolant temp sensor coming in here. You could put air temp sensor. I'm going to do air temp because, you know, hotter air, cooler air, you need to add fuel or take fuel away with air temperature and things like that. And if I'm stuck in stop and go traffic and my air temp's getting up and it's up to 180 degrees, or, you know, I want to go in there and do something with fuel, maybe some timing removal, to kind of help that out so it doesn't cause me any issues. And we'll get into that too. I'll show you what I'm talking about. But just remember for later, analog 1 through 4. Okay. These are the power outputs. I'm going to connect the negative side of the boost solenoid here. The other side would go to 12 volt switched. And that's what this little note here that was up earlier is meant to convey. So let's not spend too much time here. We'll talk about pull-up sensors and ignition in and all, ignition out and all this stuff. So we're going to skip here because this is straight up just follow the bouncy ball when you're putting the software in to your laptop. These buttons here, these are up in the top there, and these are things that you're going to want to kind of look at and make sure you understand. One of the important ones here is make maps permanent. That's that little, looks like a chip with an arrow pointing to it. I'll show you it here in a second. Anytime you make changes, like let's say we're sitting there idling and I go in and I make some changes to some fuel. Alright, yes, I've made changes to the fuel, and you should see a result as you're driving the car at that point based off the changes you made. You pull into a parking lot, you turn your car off, you go in and get you a soda, you come back out, you turn the car on. Those changes you made are gone now. You still have your base settings and all that, but any changes you made, any edits to better yourself or better the performance, they're gone. Make sure every time you go up and you hit that button, because that's going to make your changes permanent. So let's say you're driving for 15 minutes, you've made 3 or 4 different changes. None of those changes are permanent yet until you hit that button. Okay, so remember that. These things will get into all the rest of these too. Tables. Okay, so it just talks again about what tables you have, 16 by 16 and so forth. So I'm going to go ahead at this point. We'll stop on page, what page is this? Page 10. Alright, so next time we'll pick up on page 10, because I want to real quick show you the software. Alright, so this is the software. Now what I'm going to do real quick is, and you'll need to do this as well, you're going to want to save a file for you. And so before you make changes, go ahead, since you're going to be using this map here, this you know, this isn't the switched maps 1 and 2. This is just your straight up normal map you got, you're going to want to go ahead and save project as, name it what you like. Saturn Boost, Top Dog, Hot Dog, it doesn't matter. But you're going to save project as, and you're going to create your project so that every time you come in, you're going to save it. Whatever changes you make here, you're going to want to save it. So we're going to load a project because I've already kind of done this. Saturn Test Play, open. And there's one other thing you're going to want to do every time you open this thing up, just to make sure you're where you're supposed to be at. You go into Setup, Scales Configuration, and you're going to want to go in here, and the same thing, you're going to want to save and make a file with your name on it, what you want to name on it. Top Dog, make sure it's the same file. But I've already done that, so I'm put load, Saturn Test Play, and open. Okay. Now, why that's important is because, especially in this map here, what I've done, we're going to talk about what these maps are. This is a 3D map, okay? These two down here are basically your 2D maps. This one has 3 axes on it. It's a 3D. This is the horizontal axis down here. That's going to be our boost, and I set that up, and I'll show you how to set that up. Our atmospheric pressure, I should say. This is our RPM. That's easy enough to see. I've got mine set to 6600. This isn't a Honda, then I'm revved to 10,000. I got it at 6600. And then this right here is your third portion of the 3D graph. So for instance, let's say I'm just going to go in here. Alright, so I just changed all these cells to 20. Here is the first D of the 3D, here's the second D, and the third D is the height. So 1, 2, 3D. Okay, so this is a 3D map. These maps, like I said, are 2D. You're going to click on this, and you basically you can only go in here and just basically add, it's just a 2D map. You've got this axis and then what it does. So this axis and then a height axis, I guess you could look at it as. Same thing here. Okay. So these numbers right here don't really mean a whole lot of nothing right now because these are unreal numbers. I've been in here playing with this thing, changing parameters and stuff like this. Like right here, you see where it's 120. You see the peak right here. If I just go in there and hit that, it goes back down. Okay. Now, like I said here, if I wanted to keep this, I would want to save, click that, and save it. So next time I go in here and I load Saturn Test Play, it's going to come right back here where I was at. Okay. So here's those buttons I was telling you about. Here is that button that's supposed to make maps permanent. Of course, it's grayed out because it's not connected to the Det3. It's not connected. There's nothing truly happening. All these other ones, we'll talk about those later. This is your fuel table. Here's your ignition table. Again, it's a 3D map with 2D corrections. Two 2D corrections on here. These are your pulse width tables. Same thing, 3D, 2D. That's pulse width modulation table number 1, pulse width modulation number 2. Here's your log windows. So this is a data logger. You can select your sensor, like say I want to monitor what the air temp sensor is doing. I can click on it, record it, versus RPM, all this stuff. This is your road dyno. Now, important thing to talk about here is this road dyno, if you go into parameters, okay, I've already titled this Saturn rear mount. Now, I know from some research online that the coefficient of drag for these cars is 31. I don't know if this is true or not. This is meters squared, so 2.2 meters squared, frontal area. You could measure that, and you can go in here and put some kind of close number. I do know my car runs about 989 kilos. I know that. This RPM ratio, apparently, if we go in, now these are not my tire sizes, but if we go in and we put in tire, 225, 50, 16, or whatever we're doing, and we know our gear ratio, gearbox and tires, this, you hit calculate RPM ratio, and it should give you a number here that should be, as I guess, as correct as it can be off the data that you put in here. Now, the cool thing about this is this a Mustang dyno? No, it's not. Is it a chassis dyno, engine? No, it's not. But let's say that okay, I've got my stuff all squared. I got all my fuel done. I got my ignition done, and all this stuff. And so I hit the road dyno, and I make a run. Well, and let's say that I'm running 10 pounds of boost, and it says I'm making 500 horsepower. 10 pounds of boost, 500 horsepower. That's, oh my gosh. Of course, that's not going to be the case. So let's say then at that point I go in and I make some fuel changes, and I make another run, and I overlay those two runs. So run 1 was 500, run 2 is 550. So there's a 50 horse difference based on the changes that I made. That's the important thing, because even if all your data in here is wrong, okay, yes, you'll get an incorrect true horsepower number, but you know, at least when you go over here and you make fuel table changes and things like that, and you do other dyno runs, you can see if those changes were positive or if they were negative. If I was 500 on my first and now I'm 475, well, whatever I did lost 25 horsepower. So that's how you can use this. Even if all this stuff's not 100% spot on, you can still use it to make some changes on the car. So keep that in mind. There's a cool thing here where I was watching the guy that I said the thing was in Polish, but it had English subtitles. He goes in and he shows you how to operate this, and I'll show you too, so you don't have to worry about subtitles. But he's able to make a run, and of course he's got all his little his lines acting crazy, you know, RPM, and so forth. And your air fuel ratio is going rich, lean, rich, and things like that. You can actually make an entire drive, and then you can go out, as you've been recording this, you can go into different areas of that graph. You can highlight those areas, just a specific area. Let's say one where you were up at 6600 RPM, if your ratio was 11.5, your boost pressure was 20. You can select that certain peak right there, click on it, and then go into road dyno, and it'll show you the horsepower that was at that point. So again, unless these are spot on 100% accurate, you're going to get skewed numbers, unless you're looking at it from the standpoint of one skewed run to another skewed run. You're going to see some real horsepower gains or losses. So that's how I would use that. In other words, it's not meant to replace a real dyno. Okay. So I think at this point I'm going to go ahead and sign off for this one. We're going to come back, and obviously we're going to get into this stuff, and I just don't want to go for 4 hours and you wake up about midway and you realize you lost the last 20 minutes because you fell asleep. So save that. Anyway, so yeah, we'll get into how you get inside these numbers. Here's where the reason I was talking to you about the analog 1, 2, 3, 4. This is where that's going to come into play here. Let's see here, analog inputs configuration. If you notice, 1.61 bar, 1.61 bar. Okay. Air fuel ratio 8 to 18. Air fuel ratio 8 to 18. So what you're doing here real quick is you're just going in and you're tightening up the available cells you have to tune off of. In other words, if I'm only going to be running 1.5 bar, so what is that? 14, that's 21 pounds. Okay. If I'm running only 1 bar, which would be what, right here, 1.09. Why do I need this up here? Why do I need these higher bar numbers. I'm not going to be tuning for this because I'm only going to be running 14.7. So I would want to come into here and I'd want to tighten this up to where when it gets to this cell, these cells right here, it's at 1 bar. So instead of 161 being here, I'd have 1.09. Okay, and then that would stretch out these numbers and give me more concise or more precise tuning ability. Okay, because this thing already has the ability to kind of interpolate. So you would say, like, let's say here I've got 10 put in here, 10 units of fuel added at what? Well, let's use a little better world example. So let's say right here we're at what? We're at 7 pounds of boost. Wait, 0.7. Yeah, sorry. Yeah, I had a moment. Man, it's 9:20 here. I'm a little sleepy. So 1 bar would be what, 14.7, somewhere in there. So half a bar is going to be 7 thereabouts. So let's say it's 7 pounds of boost, and at 4,500 RPM, which is right there, we know from our air-fuel ratio and tuning and testing that we need 60 units of fuel at that point. But we notice at 1.6 bar at 6,600, we need 100 extra units. So what I would want to do here at this point is to go in and basically highlight all this, right click, and interpolate. Now, this isn't going to get me out of jail free, but it's going to start kind of building a map for me to where it makes more sense. Now look what happened here. 4,500 RPM, 161 bar, I got 0 fuel being added right there. That's no good. And so you can take this 3D map over here and look at that and say, man, that's all over the board there. That don't make any sense. And so I can go in here, wherever I go with my cursor, you see it turns yellow over here. These are the cells it's going to change. So let's say right here, I want to go in and I'm going to highlight all these. And I'm going to hit shift and then plus. Watch. See, I'm adding fuel. And then I'm going to go up to the next set. And I'm going to add some more fuel right there. I'm going to try to start kind of making more sense of what this map looks like. Now this isn't a game of just going here and build a pretty pyramid on this side, make it nice and smooth, because the way your engine runs, your volumetric efficiency may be better or worse, say here, than mine is. And so maybe yours just is a whole lot more efficient. And so because of that, you need more fuel here where I don't. That's the difference. That's where when I'm tuning and I'm showing you the tuning and stuff that I'm doing, and it would be ludicrous for me to send this map to you and say, here you go, just punch in the numbers. You'll be just like me as long as you run 10 pounds and I'm running 10 pounds. And no, it doesn't work like that. Okay, now this could be like a quote unquote starting map maybe, but you'd still want to be hella careful, because you try to rely on this too much, and next thing you know, you're popping your motor and you're saying, Kurt's, that butthole, his little base map blew my motor up. No, you blew your motor up. I told you ahead of time, don't do that. So anyway, we're going to stop it here. I'll do part 2, 3, 4, however many it takes, because at some point, obviously we're going to migrate off of this. I just want to get you real familiar with this so you understand why we're doing what we're doing when we're wiring it in. So, but at some point we're going to move from this into an actual physical view and video of the wiring in and which ones. Like I said, I'm going to work on an actual diagram that shows the like, let's say I'm going to show like a you dirty dog. And yes, it's probably going to be paint, but no. How about this? So I'm going to have like the all the different sensors, the Det3, the stock ECU, and then I'll go through and say, okay, the yellow wire from the crank sensor, okay, comes in and goes into pin I don't know, D7, okay, something like that. So I'm going to have all that set up to where you know, and then from here that same yellow wire is going to come out of whatever pin, and this would be that 1 through 20 off the Det3. It needs to come out of number 6 over to A622 in the stock ECU. So all this is going to be mapped out for you, so you know exactly what to do and where to wire everything in. Where should you intercept it, should you tee into the line, that kind of thing. So all that's going to be worked out. But like I said, some changes may have to happen just because I'm just going by what I'm told to up to now. And to get this out there and get you started on it, that's kind of what's going to have to happen. All right, we'll talk to you next time.